Okay, so what we're going to need for your answer to A, if we want to find a unit vector in the opposite direction of u minus 2v, is the negative of 1 over the magnitude of u minus 2v, and then multiply that by your vector u minus 2v. So let's get at what the actual numbers are. So u minus 2v is going to be the vector u minus 2 times the vector v. And so that's going to be u minus, and then I'm going to multiply that through. So I multiply 2 times every coordinate in there. And then I'll get a single vector here. I'll have 2 minus negative 8. Then I'll have 4 minus negative 4, which is 4 plus 4. And then I'll have negative 1 minus 2, which is negative 3. Okay, so that's my vector u minus 2v. Now let's get the magnitude. And that's going to be the square root of each of these coordinates all squared. So negative 6 squared plus 8 squared plus negative 3 squared. That's going to be the square root of 36 plus 64 plus 9. And that should give me the square root of 109. And so my answer to part A, well, what we had up here at the beginning is going to be the negative of 1 over the magnitude times that vector u minus 2v, which is this. And this is a constant, so I can just multiply it by each thing in there. So when I multiply these two together, the negative signs will cancel out. And I'll have that. And when I multiply that by the second one, oh, that should be a plus. My bad there. Okay. I'll have negative 8 over square root of 109. And then when I multiply these two together, the negative signs will go away, and I'll have 3 over the square root of 109. So this is the answer to part A. That's your answer to part A. Okay, so now let's look at part B. Find a unit vector which is orthogonal to u. Okay, so u is that. And now I'm going to have another vector w that I'm just going to call ABC. So u and w are orthogonal if their dot product is equal to 0. So if I take their dot product, I'm going to get 2 times A plus 4 times B plus negative 1 times C. So if they're orthogonal, then that has to be true. So I'm going to add C to both sides. So I can refine W now. Instead of C, I can have 2A plus 4B. So I'm free to choose the A and the B. So suppose I let A be 1 and B be 2. Then I claim that this vector, 1, 2, and then 2 times A, so 2 times 1, plus 4 times B, so in this case 4 times 2, that's going to be 1, 2, and 2 plus 8, which is 10. I claim that that vector is orthogonal to U, which it is. I can check that. If I take their dot product, I'm going to get 2 times 1 plus 4 times 2 plus negative 1 times 10. And 2 times 1 is 2, plus 8 minus 10 is equal to 0. So this vector W is orthogonal to U. But your instructions say to find a unit vector. So we just have to normalize this vector. So what we want is going to be 1 over the magnitude of W times the vector W, and that will answer part B completely. So the magnitude of W is the square root of 1 squared plus 2 squared plus 10 squared, which is the square root of 1 plus 4 plus 100, which is the square root of 105. So the vector that we want is going to be 1 over 100, square root of 105 times this vector. So our answer is 1 over the square root of 105 times this vector. And I'm just going to multiply each coordinate in there by 1 over square root of 105. Okay. And so that's our answer. And if you take the dot product of those two, you get 0. And this is a unit vector. So I hope that this helps you. And that ends the video.